Alrighty, so far in 1-4 we have done some factoring, we've simplified some rational expressions, we've multiplied them, we've divided them. All we've got left to do is adding and subtracting. Easy peasy.
Famous last words.
I mean, if we don't do something first, sometimes there's a reason.
So why does Canvas have to be so slow?
Because it's Canvas and school Wi-Fi is beautiful and totally reliable. Because I'm definitely not recording this class. Alright. So if we think this through with just numbers without looking at our rational expressions, if we're trying to add some fractions together, what do we need to have first? Common denominator. We gotta have common denominators in order to add or subtract fractions. So what is a common denominator I can do here for 4 and 6? 12. So if I want to get these both to have a common denominator of 12, what am I multiplying this fraction by? 3, but it's 3 over 3 because I'm not actually changing my fraction. I'm multiplying it by a funny looking 1. So we get 9 as our numerator here. What are we multiplying this fraction by? 2 over 2. Because again, I'm not changing my expression. I'm just making it have that common denominator. We're finding the piece that's missing. So we get 4 over 12. So what does this combine together to be? 13 over 12. Yep, you could do 1 and 1/12. We can also just leave these as improper fractions. Leave it as 13/12. Totally fine. You could also look here and go, oh wait, I could simplify first. Simplify this down to be 1/3. I mean, we'd still wind up at the same spot, but you can simplify too. What is our common denominator going to be over here? 15. So you can also do it this way where we think about, what are we multiplying the 2/3 by? 5 over 5. So that's going to give us 10. And we're subtracting our 1/5, which we multiply by what? 3 over 3 to get to that common denominator of 15. So you can either do them as two separate fractions or you can combine them together since they do have that common denominator. Two totally different ways of writing it, but two equally usable ways of writing it. What is this going to simplify down to be? 7 over 15. Okay, so super important for them to have common denominators before we try and add or subtract those numerators. I wonder what we're going to have to do with our rational expressions today. Oh my gosh. Okay, we're going to go through this, I promise. So I'm going to zoom it in just so we only have to look at one at a time. So we're going to try and add these two pieces together. We've got 5 over 4x squared y. And we're trying to add 3 over 14xy cubed. So what we need to figure out first is what are we going to get these to be for their common denominator? We need to figure out what needs to be shared. When in doubt, look at each piece individually. 4 and 14. What is something I can multiply both of those, or that has both of those as a factor? I heard a couple of them. The 28 is the smallest one that I see. Because 4 is 2 times 2, 14 is 2 times 7. So we need a 2 times 2 times 7.
Could you also multiply each?
You could take 4 times 14 and do that. You're just going to then have to simplify at the end. because we would have common between our numerator and our denominator.
Would it be 28
Mhm. Yep. Because then we look at our x's and say, well, I have one x and I have two x's, so we know we need to have at least two x's. And then if I have y and y cubed, I've got to have up to y cubed. So when we're looking to figure out what we're multiplying each of our fractions by, this is what we're trying to get our denominator to be. This includes all the pieces we need. So what do we need to multiply this denominator by in order to get it to be 28x squared y cubed? 4 times what gives me 28? 7. X squared. Do I need to do anything to my x squared to make it be an x squared?
No.
No. How about for my y? How do I get it to be a y cubed?
7y.
Y squared. So I need to multiply my denominator by 7y squared, but I can't just multiply my denominator. However, I can multiply by a weird looking 1. What this does is if I multiply this left fraction by 7y squared over 7y squared, we get 5 times 7y squared, which is going to be 35y squared. And our denominator here is our 28x squared y cubed. And then we're going to do the same thing with the right fraction. What do I need to multiply this denominator by to make it be 28x squared y cubed? 2x. But I can't change my expression, so I multiply by a weird looking 1. When we multiply those together, my 3 times 2x gives us a 6x. And our denominator is going to have our 14 times 2 is 28. X times x gives me x squared. That y cube's just chilling. Now that they have those same denominators, I can add them together. So our denominator is going to be that 28x squared y cubed. Can I put together 35y squared and 6x? Can I combine them together? Smoosh. Because they're different variables. It's like 35x squared and 6x. I can't combine those together. They have different variables, different powers. We can only combine them together if their terms are exactly the same. Is there anything I can factor out of the both of them? Could we simplify it at all? As I say, see, think about if 35 and 6 have any common factors. No. So this is our answer. I'm trying to make it so you can see the whole thing. There we go. That's our answer on this. We are going to get to a common denominator. We're going to add our numerator. We're going to check to see if this piece will factor. A lot of the times it won't. Sometimes it will, but very rarely. But we got to get to that common denominator first. So then let's look at one of these a little more this way. And I know it's a long one. I'm going to give you guys a chance to write it down. So we have x plus 2 over x minus 6. And we are wanting to take away x squared plus 5x plus 14 over x squared minus 2x minus 24. Yep. First step is going to be to get these in factored form because I can't do anything. I mean, I could, but it's going to be super gross and I'll have to factor anyway trying to simplify stuff. But let's factor as much as we can. So our left fraction is already as factors, so I'm just going to put it down with parentheses. You don't have to, but since I'm going to need to rewrite the right ones for factoring anyway, I'm just going to do it. So we need to factor this piece, x squared plus 5x plus 14. Our a value is 1. We love that. So we need a pair of numbers that multiplies to make 14 and adds to make 5.
I swear, I haven't even use the yellow and it already does it. So then-
I don't think it works.
Oh yeah, that one doesn't factor. Fun times.
Yippee.
Ew.
So that numerator is going to stay as it is. We've got our x squared plus 5x plus 14. It doesn't factor. What about our denominator here? How about this? Multiplies to make negative 24, adds to make negative 2. Negative 6 and a positive 4. So our factored form is our x minus 6, x plus 4. Okay. So now we can see this denominator. I already have one piece that's the same, but if I want to be able to subtract these guys from each other, I need them to have the exact same denominator. So this guy is missing this piece. So we're going to take this fraction and multiply it by the piece it's missing. So we're going to choose to multiply this left fraction by
Brain had a process.
x plus 4. But again, I can't just multiply the denominator. However, I can multiply by a weird looking 1. It's a weird looking 1. I gotta close outside of parentheses. So now, when I multiply this this left fraction, I have a common denominator. They have the same pieces. We're going to want to subtract these numerators, which means here we are going to multiply out that numerator. So we're going to wind up with, I'm going to do this as 2 fractions, minus this one. Our denominator, we're going to keep in factored form. Do not multiply these out. It does not make your life easier. In fact, it makes everything harder. So our denominators are exactly the same. That's what we wanted. This one, we're going to need to multiply out. My x plus 4 times x plus 2. Whether you box, distribute, or whatever. Sorry, trying to make things match. So we'll have our x times x, giving us an x squared. X times 2 is 2x. 4 times x is 4x. 6x plus 8. If you do that in a couple of steps, totally valid. If we can do that without taking a couple of steps, love it. Because then we're going to take our x squared plus 6x plus 8, and we are going to subtract our x squared plus 5x plus 14. And if you want to do that in one fraction, just be really careful. Make sure we remember we're subtracting all of this. So you would put your minus and you put parentheses here. Or you can come here and do this in parts. However works for your brain. There's lots of ways to work through this. This is just kind of the most common way I see people go. Is that we take our x squared minus x squared. What's going to happen with our x squareds? Cancel out. We have no more x squareds. We have 6x minus 5x. Just 1x. We have 8 minus 14. Minus 6. I was going to say, then we look at our answer and see if we can simplify. Because this is the same thing as having x minus 6 like this. And our x minus 6 can cancel out with the x minus 6, giving us a final answer of 1 over x plus 4. So make sure we look back and simplify when we're done. But it's all about getting to that common denominator and combining like terms. We're going to practice this several more times. Here's pen. Okay. Questions on this one? Cool. Here's that little spot. All right. Here's 2 newlets. I'm going to zoom it in just because I know sometimes it's very small if I don't. So let's look at this one. We've got x minus 4 over x squared plus 5x plus 6. And x minus 1 over x squared minus 4.
What is up with my pen?
I don't know.
First, my yellow bright doesn't want to put my letter.
The brights are like, they're a little gritty almost sometimes, so they get grumpy.
The blue and the reddish pink seem to work fine. I haven't tried the white one yet. But the other three, they're just like...
It works very well on printed. It tends to blend a little bit more with other inks. All right, so we're gonna come through and we're gonna factor everything so that we can figure out what we need to do to our denominators to get common denominators. So our first step needs to be to figure out what we're doing. So our numerator over here already is a factor, so I'm just going to put my x minus 4 down here. And then we need to factor this guy. So again, we can think about our factoring. Pair of numbers multiplies to make 6, adds to make 5. What pair of numbers multiplies to make 6 and adds to make 5? 3 and 2. So we're going to have x plus 3 and x plus 2. Okay, that's workable. On our right side, our numerator is again just kind of chilling. It's already written as a factor. Oh, that's a 1. I'm good at numbers. And our denominator is a difference of squares. So we have as our factored form, what is our factored form on that one? X minus 2, x plus 2. Does not matter which one's in front. So we got to put things in factored form first. It does make everything doable. If you don't put them in factored form, I don't know how you would.
Do the x plus 2's cancel out?
Because they're both in the denominator, they do not.
Okay.
But we need to get to a common denominator because we're trying to add these things together. So if we're trying to add, I need to have a common denominator. So I see 3 different things in the denominator. So our common denominator is going to have all the different pieces that are down there. It's going to have an x plus 3 from here. It's going to have the x plus 2 that's in both of them already. They already both have that one. And then they also need to include that x minus 2. However many different pieces there are, it needs to have those. So what do I need to multiply this fraction by? What is this one missing? The x minus 2. So we're going to multiply this one by x minus 2 over x minus 2. What do we need to multiply this one by? Yes. So I'm just grabbing a bright color. So this one we need to multiply by our x minus 2 over x minus 2. And this one we need to multiply by the x plus 3 over x plus 3. That'll fix our denominators to be the same. And we are going to multiply both of those out because we are trying to combine together our numerators. You can do it all into one fraction, so you don't have to write that numerator or the denominator a gabillion times, especially when it's addition because it doesn't play games with our signs. If it's subtraction, you just got to be really careful about signs. So as we're doing this, we're going to get our x minus 2 times our x minus 4. And so we're going to have our x squared minus 2 times x and minus 4 times x. So we're going to have a minus 6x. And then we have our minus 2 times minus 4 giving us plus 8. Then we're going to do, there we go, my x times x giving us x squared over here. Minus 1x and a plus 3x gives us a positive 2x. And then we have minus 1 times 3 giving us minus 3. And we are adding these two pieces together. Okay, so everyone see how we get all those pieces? Now what we're going to do is we're going to combine together our like terms. So there we go. That was weird. I was like, why'd you disappear? So in our numerator, we've got our x squared plus x squared. So we have 2x squareds. We've got minus 6x plus 2x minus 4x. And then we have 8 plus negative 3 plus 5 over our x plus 3, x plus 2, x minus 2. I encourage you to look and see if it will factor. This one won't, but it's a good idea to double check. I'm almost out of space. But this is our answer. So when you get down here, you should check and see if this factors. This one won't. We don't have any numbers that are going to multiply to be 10 and add to be negative 4. Questions on that one? Because it's a lot of stuff. Yes, dear. As long as, yes. For me, yes. I'm okay with that. Just make sure that you're aware so that if you're trying to like cancel anything out, that means you have 2 separate pieces. Yeah. As long as I can follow it, we're doing pretty good. Yeah, as you're working through stuff, if you can do things in like semi-order, that would be fantastic. Instead of doing like thought cloud all over the place. But questions on this one? Any more questions on this one? Because you guys have good questions. Let's look at this guy. And then we're going to start combining things.
Oh. Lord.
It's okay. We'll be okay, I promise.
When am I ever?
I don't know. So let's look at this guy. So we have a whole number, something that looks like it's already kind of in factored form, and then we have this 2 over x squared minus 4. So really we only have one piece in this whole guy that we can factor. I'm going to move my mouse out of the way because he's right in the way. This guy's the only thing in here that we can factor. What is this in factored form? X plus 2, x minus 2. It's a difference of squares. So if you want to think about this and like not write it and just write it straight up like this, I'm 100% okay with that. Then you don't have to recopy anything. So what is our common denominator going to be? X plus 2, x minus 2. We're going to get everything to be right there. So if we have 3, and we need it to have a common denominator of this, what do we need to multiply the 3 by? The whole thing. That x plus 2, x minus 2. X plus 2, x minus 2. If you want to put it as your x squared minus 4, that's fine, especially for the numerator. What about our middle one? I'm just going to switch this to be black. Plus our x over x plus 2. What does this one need to multiply by? The x minus 2 over x minus 2. That's the piece it's missing. And then we have our OG guy over here who's just kind of chilling. It already has that common denominator, so we don't need to do anything to it. But now all of these pieces have that same denominator. So I can do this multiplication 3 times these. I can multiply these together, so we can add them. And then we're going to come through and subtract 2. So I'm going to make one gargantua fraction instead of writing the denominator this many times. Because we have x plus 2 x minus 2. We'll get there. We'll get there. I promise. So we have our 3 times our x squared minus 4. Oh, slowing. That's all you gotta tell me. Slowing. Sorry, I get excited. They're complicated and interesting. I was gonna say, remember that we factored that from our x squared minus 4. Means the same thing, right? Because we're multiplying it by 3. So we're gonna have 3x squared. 3 times minus 4 gives us minus 12. Then we're gonna add these guys, x times x, and x times minus 2, which is a minus 2x. I know, we're almost there. And then we've got our minus 2, just kind of hanging out. And we're almost done. Isn't that cute?
No, it's not you.
Oh, it happens. All right. Hey, guys, I need the these conversations to stop. It's super chatty and very, very distracting, not just to other classmates, but to me as well. So I'm happy to help. If we've got questions, I promise we will get to the one you're talking about. We will get there. We're just not there yet. All right, so we're going to combine our pieces together. We've got our 3x squared plus x squared. It's going to give us 4x squared. I've got my minus 2x. Just kind of chilling. And we've got our minus 12, minus 2, giving us minus 14. Is this one simplifiable? Like, could we factor this at all? What can I do to try and simplify this numerator at all? There's a GCF in it, for sure, of 2. Everything in there is even. Before I look and see if that's totally factorable, let's get rid of this 2. So if I take out a GCF of 2, we have 2x squared minus x minus 14. Our denominator is exactly the same. Nothing else changed.
Wait, doesn't 2?
Oh, 7.
Yeah.
Thank you. There we go, 7. That's 100%. Call me out if I ever do something like that. Please tell me. So then we want to see, is this thing going to factor? Do we know of a pair of numbers that's going to multiply to make negative 14 and add to make negative 1?
Yeah.
No. Because if we tried to factor this, I'm just going to switch to a gray here. It would be multiplying to make a times c, 2 times negative 7, negative 14, adding to be negative 1. Only things I can think of that multiply to make 14 are 1 and 14 and 2 and 7. Neither one of those is going to have a difference of negative 1. So it's important to check. If we've got a GCF, try and pull it out. But this is as simplified as we can go. I'm going to zoom out to the whole thing here. And then I'm just going to toss a little. This is where it's between the 2. Just so we can see. Because there's a lot of stuff up here. Questions on either of these? Prepared the slide so I could have space on it, but I then didn't use it. Fun times. Oh. Okay. We're going to look at a couple that are like some on the homework that are a little icky. I promise it's not as bad as it looks. So here's our first one. I'm going to zoom it in so you can see it, but then I'll put it back out. So we have a big fraction with h in the denominator. And then in my numerator, we have 4 over 3x plus 3h minus 1. And we're trying to take away 4 over 3x minus 1. So when we have something like this, think about our numerator and our denominator separately. We're going to look at our numerator first, and then we'll divide everything by h. So looking at just our numerator, we want to try and simplify this. So looking at this denominator here, is this something we can factor?
No.
No. It is what it is. It's just going to be this chaotic thing. 3x plus 3h minus 1. And the same thing happens with the right. There's nothing I can simplify or factor over here. It's just 3x minus 1. So if we want to subtract these two things together, what does this one need in its denominator that this one has?
Nothing. The other one.
Think about these as factors.
Oh.
The whole 3x minus 1. Because remember, we're multiplying it in. If I just tried to multiply this one by 3h, it would not exactly match this one. That'll be the big mistake people make, okay? So if they are different as factors, we got to take the whole thing. So we're going to take our 3x minus 1 is the piece this one's missing. So again, we multiply it by a weird looking 1. So this right fraction, we're going to multiply by that whole hot mess of chaos. 3x plus 3h minus 1. Remember, we're not multiplying out our denominators. We leave those in factored form. So we're just multiplying our numerators together. 3h minus 1. So when we do that, I'm just going to keep this as purple. We have our denominator here of our 3x minus 1 times our 3x plus 3h minus 1. And we're getting from our left fraction here our 3x minus 1 times 4. So our 3x times 4 gives us 12x. Our minus 1 times 4 gives us minus 4. And you can either think of this as distributing through a minus 4, or you can put minus and put your parentheses and think about it that way. I'm going to do it that way so that I can then do my 4 times 3x, 4 times 3h, 4 times minus 1. So we're going to subtract 12x plus 12h minus 4. All right. We almost have this piece simplified for us. 3x minus 1 is our denominator. 3x plus 3h minus 1. And in our numerator, we need to simplify this. We've got our 12x minus 12x. They cancel out. They go away. 12x minus 12x. I have nothing minus 12h.
That negative.
Make it a negative 12h. Because we have this minus our minus 12. Minus our 12. And then we have negative 4 minus negative 4.
That would cancel out.
They're going to cancel out because that's the same thing as negative 4 plus 4. So those guys cancel out. So we just have minus 12h in our numerator. Remember, this is still just our numerator of the numerator. I promise it's not that bad. Because what this is the exact same thing as this. We just combined our two fractions up here together. This is the numerator up here. So our whole expression here just takes this thing and divides it by h. I'm going to write it two different ways, really, really close together. We can either think of this as divide by h, works, but not the easy way. Okay? Easy way, how would I write that as multiplication instead of dividing by h? Keep, change, flip. Change the sign. Whoa. Change the sign and flip the h. 1 over h. Can something simplify here? The h. So it's super duper complicated, but all the complicated parts had to do with our common denominators. Because our answer here is what we have left over after we cancel out that h. We have negative 12 over our hot mess of a denominator. 3x minus 1, 3x plus 3h minus 1. And we leave our denominators in factored form, so that's where we stop. There's nothing else we can do. There's no factoring to do. There's no simplifying to do. That's as far as we can go. Yes, dear?
Why did we need to cancel out the h?
Because we were dividing by h here.
Oh, so you just
So that was this piece here. That was this guy. Because all of this was just looking at our numerator purple part. Okay, so if we have fractions and fractions, we can do that. Look at your numerator, simplify it. Look at our denominator, simplify it. Okay. We have one last piece of this unit to talk about. And it's called, and it's what we're going to do to rationalize pieces that have more than one thing in there. When we have factors.
Oh, God.
It's something called the conjugate, which we are going to use a gabillion times. And then we're going to get to the last kind of question probably tomorrow because we only have 5 minutes left. And I don't want to try and speed run the conjugate because this is something super important. So we're going to talk about this and then we'll probably get an extra day on section 1-4. Because, yeah, we're not going to get through absolutely everything. Well, I'm going to push this back. It's going to be 14. And I will talk with the other teacher about this. So I'm pushing that back because I'm not going to get all the way to the polynomial question that I know you guys had earlier. And I'll want us to practice with the conjugate again tomorrow. Because the conjugate is something super duper important. We are going to use this a lot this semester. We are going to use this next semester. Conjugate is a thing we use. What it is it's a way to get our square roots out of the denominator. Because we did that with our rationalization. When we did that with square root of like 3. But when we have a sum like this, what we have to do to be able to get the square roots out of the denominator is we're going to take whatever piece we have here and we are going to force it to become a difference of squares. That will make our denominator become not a square root. So what we're going to multiply by to get rid of roots in our denominator here, zooming out, there we go. So I was trying to zoom it in to make it easier to see. I'll get rid of the highlights. I feel like that makes it easier. What we pick to multiply by to get our roots out of the denominator here is going to have the exact same pieces, our square root of x, square root of y. But instead of a plus, we're going to use a minus. It uses the opposite sign. Same terms, opposite sign. This forces it to be a difference of squares. If I multiply out this denominator, the way we did when we were multiplying our fractions, we're going to have our square root of x times square root of x, giving us square root of x squared, so we get just x. We're going to get square root of x times y minus square root of x times y. So those two pieces are going to cancel out. And then we're going to be left with minus square root of y times square root of y. Minus y. So if we multiply this out, we get a difference of squares. We are going to practice with this tomorrow.
Is the key to this just like flipping the sign when you
Yep, a 100%. It is just the same terms, opposite sign. 100%. And then we multiply them together. We'll talk this through more tomorrow. We'll practice using our conjugate, and we will finish out with the one that says express it as a sum of terms, because I know there's at least one like that on the homework. We'll talk through those tomorrow. And then we will probably still have time to get started on 2-1. I'm pushing the homework another day because we did not get through the last 2 types of questions. So we'll practice more with the rationalization, and we'll deal with the polynomials tomorrow. But that means it's not due tomorrow because we didn't talk about those kinds of questions. Piss. So Thursday. So this lets us get at least through our definition, and then we will practice with it tomorrow. And we'll talk about the polynomial ones. So 1-4 will be due Thursday. I know. I'm sorry. Oh, whoa. Yes, I just got I got a notification that I got cited for.
What? Is it packing?
No. I'm trying to figure out what it was that gave me the notification on my watch so I could look at it. No, I don't want to update that. Wait, clear the notification. Yeah, I did. Have a great rest of your day. See you tomorrow.
I'm kind of glad that it got pushed back a day.
She did. She announced a new album. What?
Wait, what?
Yeah.
Wait,
Yeah.
what?